Hello everyone, this is Sakshi and I welcome you all to my EduTech platform, Way to Learn. So today I am going to solve some of the problems from Standard 9 and today's topic is from Chapter 8 Motion and its equations of motion. So there are three equations of motion and these three equations of motion give a relation between a velocity, acceleration, time and distance or displacement. Right? So we are going to see what are these three equations of motion. We are going to solve the problems from there. So the first equation of motion is V is equal to U plus AT, where V here is the final velocity, U is the initial velocity, A is the acceleration, and T is the time. Second is S is equal to UT plus half AT square, where S is the distance or displacement. And third equation of motion is 2AS is equal to V square minus U square. So these are the three important equations of motion and let us solve some of the problems using these. First problem says that a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and the distance traveled by the train for attaining this velocity. So here, if you see, the given is the velocity attained, which is 72 km per hour. Time taken is 5 minutes, which is 300 seconds. And we have to find the acceleration and the distance traveled. The formula is acceleration, which is A is equal to V minus U by T. And the one which relates the velocity and acceleration is the third equation of motion, which is 2AS is equal to V square minus U square. So, in my last video, I had spoke about acceleration. So, this is the first formula from that video. So, you can look into it. And let us see the solution where the train travels at some velocity. Okay. So, the initial velocity is 0 km per hour and the final velocity is 72 km per hour. Right? So in our first case, we have to find the acceleration where initial velocity is 0 km per hour and final velocity is 72 km per hour. And I have converted this kilometer per hour to meter per second by multiplying by 5 by 18. So now I get my acceleration to be 1 by 15 meter per second square. And in my case too, I have to find the distance. So I have the acceleration and I have the final velocity 20 meter per second and I have the initial velocity and the distance. I have to find the distance, right? So I can find distance using the second formula, which is 2AS is equal to V square minus U square, and on substituting in that formula I get S to be 3000 meter, which is 3 kilometer. That is, the train travels 3 kilometer with the acceleration 1 by 15 meter per second square. So let us see our next problem, which says that a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. So it is the same situation. So it is given that we have initial velocity and the final velocity, and time here is 5 seconds. We have to find the acceleration and distance covered. The formula is the same, and the solution now. We have the initial velocity and we are going to convert that kilometer per hour to meter per second. So just multiply by 5 by 18. So similarly for the final velocity I get it as 10 meter per second. So in time t is equal to 5 seconds and the acceleration is 1 meter per second square. And to find the distance I can use this formula. So I multiply by 2 into a into s, which is 2 into 1 into s, is equal to V square minus U square. V is 10 square minus U square is 5 square. So I get my distance to be 75 by 2. So the distance will be 37.5 meter. So the distance traveled by the car will be 37.5 meter with acceleration 1 meter per second square. So let us see our next problem, which says that a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? So we have to find the distance, right? So we have initial velocity, acceleration, time, and we have to find the distance. So which formula will suit this? The formula that suits is is S is equal to ut plus half at square. So this is the second equation of motion which relates the distance, time, initial velocity and also the acceleration. So how do I find the initial velocity to be 0 meter per second? Because I have been told that the motorboat is starting from rest. So when it is at rest, my velocity will be 0. So that will be my initial velocity. So I substitute u to be 0. So let us see the formula. Let us see the solution. And yes, here is the motorboat. So it starts from a point and moves with some acceleration. And here the initial velocity is 0, acceleration is 3, time is 8. And I am going to substitute in the formula which is S is equal to ut plus half at square. So here my first term will vanish because it's multiplied by 0. I'll have the second term. So on doing that, I get a distance to be around 96 meter. So I hope this is very easy for you. Let us see your last problem, which says that a bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Find the speed acquired and the distance traveled. So given us here initial velocity which is 0 because it is at rest, acceleration is 0.1 meter per second square, time is 2 minutes which is 120 seconds. And we have to find the speed or the velocity and the distance traveled. So the formula here is the final velocity is given as v is equal to u plus at and distance is given as s is equal to ut plus half at square. And let us see the solution where we have these given. And in our first case, we are going to just directly substitute in the first equation of motion, just v is equal to ut plus u plus at. So u here is 0 and I have the second term alone which is a into t. So on doing that, I get my velocity or speed of the bus to be 12 meter per second. And in case 2, I have to find the distance. So I'm just directly going to substitute in the formula. And my first term will vanish because it is multiplied by 0. And the second term will be remaining. And on doing that, I get my distance traveled to be 720 meter. So I hope you understand these solutions. And we are going to solve more problems based on this equations of motion. So stay tuned for more videos and thank you. Like my videos, share my videos and subscribe my channel, and also do not forget to hit the bell. So only when you hit the bell, you're going to get my notifications. So tada! See you tomorrow.